348 25 817 005 13 29 616 0805 13 13 370. Email bestoptions01@gmail.com. Best Option, a must-have video CD for schools and colleges. Grab your copies now.
Good day, students. Good day, sir. I'll be taking you chemistry, and I believe from the knowledge of chemistry of what we heard about it, based on what chemistry is all about, the fear students do have about chemistry cannot be overemphasized, because most students think this course is very, very difficult. But I believe by starting from the grassroots up to wherever we are going to stop, I believe you have all cause to glorify the name of Almighty God at the end of this class. So you are welcome once again. Thank you, sir. The first topic we are going to be discussing this morning is nature of matter and separation techniques. What is matter? That's the first question. And that's the basic of chemistry. By definition, matter is anything that has mass and occupies space. That's the definition. So in this sense, by the definition of this term, anything that has mass and occupies space, I don't think there is anything on earth that will not either have mass or occupy the space. So in this sense, that means everything around us is a form of matter. So matter exists in three states. States of matter. The first state in which matter exists is solid. The second state is liquid, while the third state is gas. So that means if anything exists in any of these three states, that substance is said to be a matter. So that means that you are sitting here, you are a form of matter. The chair you are sitting on is a kind of matter. Likewise, your pen as well as your books, your writing materials. So in other words, as a student of chemistry, it is very essential for you to be able to distinguish between these three states of matter. So we are going to look at the differences between them in terms of some major properties. Some of these are, differences between the three states of matter. We have properties. Some of the properties that we are going to be looking at, the solids. I want to have it in tabular form, liquid, and gas. The first property is shape. Shape. In terms of shape, we can say the shape of solid is definite or fixed. That is, solid substances have definite shapes or fixed shape. The shape we are talking about can be in the form of cuboid, cylindrical, or spherical, as you have learned in your mathematics. Those are the kind of shapes we are referring to. But liquids occupies shape of container. That means liquids do not have shapes of their own. Like for instance, if you have a liquid water or common oil, be petrol or kerosene, You cannot say precisely the shape of that material. But when you use a particular substance to take certain amount of that liquid will occupy the shape of that thing. Like for instance, you can use a cup to take some quantity of water. The water will take the shape of that cup. So they don't have shape of their own. But in terms of gases, they have indefinite shape. The shape of gas is indefinite, meaning they do not have shape whatsoever. So later in our class, we will be discussing a kind of movement in gases. We call it zigzag manner. We are coming to that. The second properties that we shall be looking at is volume. Of course, from our basic terms, we know that anything that has a definite shape must have a definite volume. Like for instance, when you say the shape of a material is cylindrical, of course we know how to calculate the volume of a cylinder. If some materials are given, volume of a cylinder is pi r square h. If it is spherical, there is a formula for that, provided you know the radius of that material. So anything that has a definite shape must have a definite volume. So the volume of solid substances is definite or fixed. Why for liquids? So because they take the volume of their container, the shape of their container, definitely the volume of liquid substances can also be approximately equal to the volume of the container in which they are occupied. So we say they occupy volume of container. While in terms of gases, a gaseous substance, as it is being mentioned earlier, do not have shapes of their own. So definitely their volume is also indefinite. The third property is going to be density. Density. What we mean by density from our general terms or general knowledge, especially in physics, is mass of a material per unit volume. So that means the higher the mass of the material, the higher its density. And when the material has a larger volume, because density is inversely proportional to volume, we expect it to have a low density. So in terms of solid substances, they have definite shape, definite volume, so they have a very high density. So we can say their density is very high. For liquids, we can say they are high density. High in the sense that they have density, but it's not as high as those of liquids. While gases, they have a very low density. The next property is compressibility. Compressibility. Compressibility by definition means the change in the volume of a material with respect to pressure change, be it increase in pressure or decrease in pressure. When you apply too much pressure on a substance, you expect the volume to change appreciably. That is what we mean by compressibility. So in terms of compressibility, solids are incompressible. Incompressible. What we mean is that any solid substance, you can't compress it. Let's say for instance, you have a stick of chalk and you try to apply pressure. The most important thing that will happen, the only change that will happen with that chalk is for it to change from the solid chip into powdery form. That powdery form is also in solid state. So there is no change in state. Are you getting it now? So solid materials, when you apply pressure on them, their volume remains the same. Is that taken? While in terms of liquids, the same thing. We express the same thing here. We experience the same thing. So liquid substances are also incompressible, because when you compress liquid, especially liquid water, when you apply too much of pressure on water, if it flows, there won't be change in any volume. So they are